Today we're going to look at something called diamond problems. You'll see that diamond problems are kind of like little puzzles that have 4 numbers in them, and all the numbers are related to each other. Take a look at the one on the screen in front of you. We have 3, 15, 5, and 8. And if you notice, when we multiply across 3 times 5, we get this top number of 15. And when we add 3 plus 5, we get the bottom number of 8. Okay, so the way that diamond problems work, in case you missed class today, is that we have 2 numbers on the side, and when we multiply them, we get the top, and when we add them, we get the bottom. Or we can say that the top is our product, and the bottom number is our sum. One more way that you might see this written is you'll have x and y, and then the top is xy, or x times y, and the bottom is x plus y. This is the way that you'll see it written quite a bit in your textbook. So when you're given a diamond problem and you just have the 2 side numbers, they're pretty straightforward. Remember, we just multiply to get that top number and we add to get the bottom. So 4 times 5 is 20, and 4 plus 5 is 9. And then the one on the right, we have 2 negative numbers, but the rules are the same. I do negative 3 times negative 1, and I get a positive 3 for the top. And then I do negative 3 plus negative 1, and I get an answer of negative 4 for the bottom. Now you see one that looks a little bit different on this page. Now we're given the product, right, or the answer to our multiplication problem, and one of our factors. So we have to come up with, well, what do we do to get this number right here? Well, if I know that I have to multiply 6 and this number to get 24, I'm thinking of it like this. 6 times what number equals 24? And so I can just undo this or use the inverse operation. And I think, well, 6 times 4 is 24. Or my shortcut that you'll see here is I can turn this into a division problem. And so 24 divided by 6 gives me my answer of 4, which goes in that box over to the right. And then 6 plus 4 is going to be what I use to get my sum on the bottom. Okay, so when you're given the top and one of the left, or then one of the side numbers, it becomes a division problem. Also, if you look at the one over on the right hand of the screen, we're now given the sum of 16 and one of the numbers of 10 on the side. So I'm thinking of this as 10 plus, some number equals 16. Well, when I think of it that way, this is like a subtraction problem. 16 minus 10 gives me an answer of 6. And then I just go through now and I multiply like normal, 10 times 6 to get my product up above 60. So those are pretty straightforward when you know the 2 side numbers or if you know the product or the sum. But when they tend to get a little trickier is when you see ones like this. So on these 2 examples, we'll just kind of split them up and start with the left one. I know that I have 2 numbers that when multiplied give me an answer of 30, and when added give me an answer of 11. So one way to start this, if you're ever not sure just by looking, what you can do is think, well, I need to figure out 2 numbers that will multiply to get me 30. So I'm looking for my factors of 30. And so I'm thinking, well, I could do 1 times 30, I could do 2 times 15, 3 times 10, 4 doesn't go in, 5 does, 5 times 6, and 6 does. So that gets me back to my beginning here. So these are my factors down here of 30. So I know that in these 2 boxes has to be some combination of 1 and 30, 2 and 15, 3 and 10, or 5 and 6. And then it's just kind of a, guess and check here to see what would fit, that when you add, you get an answer of 11. And I can tell quite easily by looking here, it's going to be 5 and 6 that fit in these boxes, because 5 plus 6 gives me an answer of 11. 5 times 6 gives me an answer of 30. So my suggestion on these problems is start by listing the factors of that top number and then plug that in to see which are going to add up to get the bottom. All right, and then sometimes you'll see ones just like that like the one over on the right here, except for you'll notice you might have some signed integers. So I'm going to start the same. I'm going to start by recording all the factors of 12, and I'm going to list them as pairs. So I have 1 times 12, I have 2 times 6, I have 3 times 4, and then 4 times 3, so we're back to the beginning. Okay, so these are our 3 options here, but now I know that I've got this negative in by my 8, and so I have to kind of start playing with this. Well, I can't have a positive and a negative, because if I did, then I would have a negative product up here. So I know both of my numbers are going to have to be negative. And then I have to think, okay, well, if I have negative 12 and negative 1, I multiply them, I'd get a positive 12. But if I added them, I would get a negative 13. So that one's not going to work. If I have 2 and 6, I can do a negative 2 times a negative 6. That'll give me a positive 12. If I do negative 2 plus negative 6, I get a negative 8. Looks like we just found our answer here. But I could confirm 3 and 4 don't work. If I had a negative 3 times a negative 4, I would end up with a positive 12. But if I added them, I would have gotten a negative 7, and I'm looking for a negative 8. So we figured out here that we're going to have a negative 2 and a negative 6. If I multiply those two numbers, I get positive 12. If I add them, I get a negative 8. So that's diamond problems in a nutshell. If you still have questions about it, be sure to follow up with your teacher. Thanks for watching.